Have you ever spent, I don't know, hours, maybe even days, setting up a new project just to realize it's completely messed up something else on your machine? Yeah, we've all been there. Today, we're going to put an end to that with Docker. We're going to run our very first container and see just how it can make your life as a developer so much easier. You know, it's that classic headache, right? You install one piece of software and suddenly it's demanding this super specific version of a library that another app just can't stand. Or you show up on day one of a new project and you spend the entire day just trying to get your environment to match everyone else's. It's just a frustrating, time-sucking mess. And the answer to all this chaos? Containers. Seriously, think of them as these perfectly clean, totally isolated boxes. You package up your application and everything, and I mean everything it needs to run. All the libraries, the configuration files, the runtime itself, you put it all inside one of these boxes. And then it just runs. It's completely separate, totally shielded from everything else on your machine. Docker is the amazing tool that lets us build and manage these boxes. So our entry point into this whole new world is one single, incredibly powerful command: Docker run. Now, I know it looks simple, but don't let that fool you. This command is the key that unlocks an entire process to bring your application to life. Now, to really get what Docker Run does, we need to understand two core ideas. First up, the image. The best way to think of an image is as the blueprint for your application. It's this static, read-only template that bundles together everything your app needs to run: the code, the libraries, you name it. So if the image is the blueprint, then the container is the actual building. It's the live running thing that's created from that blueprint. And here's the really cool part. You can spin up tons of identical, isolated containers from a single image. It's like building an entire neighborhood of houses from just one set of plans. So when you type Docker run, you're basically starting this simple three-step dance. First, you issue the command. Then the Docker engine looks for the blueprint, the image. If it's not on your machine, no big deal. It'll just pull it down from a central registry. And finally, it uses that blueprint to construct and launch the building, your running container. All right, that's enough theory. Let's get our hands dirty. The very first thing any developer does after installing Docker is run the Hello World container. Think of it as the universal sanity check, that little ping that just confirms your entire setup is working perfectly. And it is really that simple. Just pop open your terminal and type Docker run Hello World. This one little line of text validates everything: that your command line can talk to the Docker engine, and that the engine can pull an image and actually run a container. Okay, so your terminal is going to spit out a few lines of text, and it's really important to know what they mean. First, unable to find image. That's not an error. That's just Docker saying, hey, I don't have this blueprint here, so I'm going to go download it. Then you'll see it pulling the image. And finally, you get hello from Docker. That's it. That's your proof of success. The container started up, did its one job, and printed that message. And then, poof, it's gone. The container exits immediately. Now, this is a super important concept. For a task-based container like Hello World, its only job is to print a message and then stop. So seeing an exited container here means it was 100% success. It did exactly what it was supposed to do. Awesome, our ping worked, but let's be real, we usually want to run something more substantial, like a web server or a database, right? For these long-lived services, we need to understand the two different ways we can run containers. So you've got two main ways to go. There's interactive mode, which you get with the -i flags. This literally drops you into a command prompt inside the container. It's perfect for when you need to poke around or debug something. And then there's detached mode, using the -d flag. This is the real workhorse. It runs the container in the background and gives you your terminal back, which is exactly what you want for servers. Let's see that in action. With this command, we're using -d to run the super popular nginx web server in detached mode. But look, we're also using the -name flag to give our container a friendly handle, my web server. You'll thank me for this later. It saves you from having to copy and paste those long random container IDs all the time. Okay, so our web server is now just humming along in the background, but how do we know? How can we check on it? How can we see what it's even doing? We need some tools to see what's going on. Your new best friend for this is going to be Docker PS. Just think of it like the task manager on Windows or the activity monitor on a Mac, but for your containers. It gives you a live snapshot of everything that's currently up and running. And the output gives you all the vital signs at a glance: the unique container ID, the image blueprint it was built from, Its status, which for our nginx server should say something like up, and of course that friendly name we gave it, my web server. But hang on, what about our little hello world container? It won't show up in Docker PS because, remember, it's not running anymore. To see your entire container history, both running and stopped, you just add the A flag for all. This is an absolute lifesaver when you're trying to figure out why a container might have failed to start. Seeing that a container is running is great, but what is it actually doing? To peek inside and see the application's output, you use Docker logs, followed by the container's name. For our nginx server, this is where you'd see all the access logs and any important messages it's printing out. Okay, we can now run our containers and we can see what they're doing. The final and honestly one of the most important parts of the whole life cycle is proper shutdown and cleanup. You gotta be a good container citizen and manage your resources. Now pay close attention because this difference is absolutely critical. You have two ways to stop a container. Docker stop is the polite request. It sends a signal that tells the application, hey, could you please save your work and shut down cleanly? Docker kill, on the other hand, is the emergency stop. It just pulls the plug, forces an immediate shutdown. You should always try stop first to avoid messing up your data. And here's another key point. Stopping a container doesn't actually get rid of it. It's still just sitting there on your disk, taking up space. To actually delete the container and free up all its resources, you need to run a separate command after it's stopped, Docker rm. But hey, here's a pro tip to make your life way easier. For all those short-lived temporary tasks, like our hello world test or maybe a quick script, just add the -rm flag to your Docker run command. This basically tells Docker, hey, as soon as this container is done with its job, just delete it for me. No manual cleanup necessary. It's awesome. And that's it. That's our core toolkit. These 5 commands cover the entire life cycle of a container. You have run to create and start, ps to see what's happening, logs to listen in, stop to gracefully shut things down, and rm to clean up when you're done. In just a few minutes, you've gone from zero to running a real web server in a totally isolated environment. You now get the fundamental ideas and the commands you need to manage any container. The foundation is set. So the only question left is, what amazing things are you going to build and run next?